Okay, it's started. Okay, hello everyone. So today's topic is complex numbers. So let's start with complex number. So what is basically a complex number? Before coming to complex number definition, what I want to tell you is, you know this natural number sets. You know, fine. So natural numbers, you know whole number sets. From where the natural number set starts? It starts from 1, 2, 3 and so on. Whole number starts from 0, 1, 2 and so on. Then the set of integers, it is basically how we write it, 0, then -1, -2 till up to minus infinity, and this side, right side, it goes like 0, 1, 2, 3 and now the next set is set of irrational numbers, and they are of the form p by q, where q is not equal to 0. P and q are integers. Yes, very good. There is another set also, and that set is set of irrational numbers. There is a point why I am telling you all these sets irrational. Fine. The next set is set of real numbers. Yes, combination of all these sets is basically set of real numbers. Now come to the set of complex number, which we will study in this lecture. So set of complex numbers. Now which one is bigger one among all? Natural numbers is basically subset of whole numbers. Whole numbers basically subset of set of integers. Z notation, sometimes we use I also for the notation. Now set of integers, and then Q. Z set of integers is set of rational numbers. We have set of irrational numbers also. It comes like in between here. We don't have like a Q intersection Q dash is basically 0. We can fit Q set of irrationals also here. Now set of rational numbers is basically subset of real numbers, and real numbers is basically set of, which one is bigger one? So this is the biggest set till now in mathematics, and we will study complex numbers today. Is it fine? So this is basically the connection. So what is basically a complex number? I'll start with definition. What is a complex number? So a complex number is of the form a plus ib. This part is called real part, and basically we denote complex numbers by z. Generally, like in real numbers we use x, but here in complex number we use the symbol z for any complex number. This is basically standard one. So a is real part of this complex number and b is imaginary part. I want to change the marker actually. It's not like working fine. So now next thing is complex equation. Real equation is basically, I hope writing is clear. There is no issue. Any issue you can talk to me. This is real equation. So complex equation will have z, and z basically having I. So complex equation will be of the form z square z. Fine. If we want to find out, like if I ask you the solution of this quadratic equation, so solution of this quadratic equation are basically, how we write for quadratic equation, minus b plus minus b square minus 4ac upon 2a. So this will be minus 1 plus minus b square minus 4ac. So It is basically under root minus 3. So iota square is here, the value of iota square is minus 1. So iota is, this is the value of iota square, fine. You all are familiar with this. So minus 1 we are getting here. So we will replace minus 1 by iota square and that will come out after, from the square root, fine. So we will write it outside the square root. So these are the roots of this equation. This is real equation now, but we are getting complex roots, fine. So it means that we have real equation which is having roots in complex numbers. So this is basically a big set, bigger than the real numbers, and we have seen one equation, real equation having roots in complex numbers. This is basically complex equation, but this is not like, for this also we can easily get the solution, but here we are writing x now. For x we are writing these values, but here we will get z values, and z is of the form a and b. So we will get this, the values in terms of complex numbers, okay. So z value we can easily get from here. Is this fine till here? Okay, now you want to write down? But because you are familiar with all these things. But the thing is, only I wanted to tell you, like, complex number you are studying, and that is the biggest set. Okay, thank you. So next move is now come to algebra of complex numbers. Algebra means what? You have studied algebra, lot of algebra. Algebra means, yes, addition, multiplication, division and subtraction. So how we add, subtract, multiply and divide complex numbers, fine. So z1 plus z2, let z1 is a plus iota b, z2 is c plus iota d. How you will add? You will add the real part with the real part of the second number. So a plus c plus iota b plus d. This is how you add. Real part separately you add and imaginary part you add separately. Now come to subtraction. So how you will subtract two numbers? The same way, real minus real, fine. So a minus c plus iota, this is how you subtract. Now come to multiplication, how you multiply two complex numbers, a plus iota b, c plus iota d. Quickly multiply a with both the numbers, so ac plus iota bd, sorry, ad, iota ad, then next number will be iota bc, then iota square, and that will be minus bd. So collect the real part separately. So AC minus BD is, this is how we basically write each and every complex number, real part first and then plus iota the imaginary part. So imaginary part collect, with iota we are getting AD plus BC. This is how we multiply two complex numbers. How we divide the two complex number, this is important one. So A plus Z1 is A plus iota B and Z2 is, if we have division and we have iota in the denominator now, what we always do, we just take the, no, here we don't say rationalize, okay, that term is totally different, that is for real numbers. So I just want to tell you conjugate of a complex number. You just understand this term first, then we'll divide. So conjugate of complex number, let z is a plus iota b, then z bar, this is the notation, z bar is the notation for the conjugate, and what we do for the conjugate, we just replace iota by minus iota. We replace iota by minus iota. So your conjugate for this number will be, so we don't rationalize, In complex numbers, we don't rationalize. What we do? We multiply by the conjugate to remove this iota from the denominator. So this will be c minus iota d, c minus iota d. Now this becomes a plus b, a minus b. So what will be the formula? A square minus b square. This multiplication I have already done. This is z2 and this is z2 bar basically. So multiplication we know how to multiply. Can I write it directly now? So this will be AC. This part will also give me real part. Okay. So when you will multiply, this will give me plus BD this time. And then collect the imaginary part. So imaginary part will be minus AD and then plus BC. Fine. And then this part will be C plus A plus iota D. So A square minus your B is this. A square minus B square. So denominator will be, I am just writing the denominator now. So this will be C iota square minus 1, so plus D square. So this is basically division. So you got to know that this basically in division we don't rationalize. What we do? We take the conjugate to remove the iota from the denominator. This basically we always do. We never keep the iota in the denominator. If I ask you now, 1 upon iota value will be what? 1 upon iota. These things we use very often. So 1 upon iota, what? Upon. So minus iota upon minus iota square. Iota square is minus 1. So value of 1 upon iota is the same way you can change others also. If I ask you 1 upon iota square, this is not like very difficult to calculate. 1 upon iota cube, 1 upon iota to the power 4. You can easily change. Fine. So 1 upon iota value is very important actually. So 1 upon iota is basically minus iota. You cannot say like if I take 1 upon A plus iota B. What will be this? So conjugate, if you multiply this by conjugate, so A minus iota B in the numerator and in denominator. Yes, quickly now you can write it down. Okay. So here we were having purely imaginary 1 upon iota. So we are writing minus iota, but here we were having combination of real plus imaginary. So this in this term we cannot say, sometimes we quickly write it A minus iota B. Quickly we write it. So but you will not be in hurry and you will. Okay. Not visible? For you people it's not visible? Okay, actually you said that I just write small. I was writing. Okay, I make it little bigger. Okay, so is this okay till here? So now come to the algebra is fine. Come to the next thing, and that is how we compare or equality of two complex numbers. You just tell me like, oh, equality of any questions. If you have any questions, you can ask me side by side. Okay, any question. So equality of two complex numbers. So equality, how we equate. So suppose this number, this complex number is equal to this complex number. Fine. So how we will equate, how we will say that these two numbers are equal? When the real part is equal to the real part and this is how we compare two complex numbers. Okay. So next thing is, this thing is something new to you. And what is new? I am writing a property in real numbers. If I have A square plus B square equal to 0, what you say simply? If A and B are real numbers, A square plus B square is 0, you simply say A 0 and B 0. You always say now this, very clear. But now see the change in the complex number. In complex numbers, if you have z1 square plus z2 square 0, can you say z1 0, z2 0? you cannot say because we have one example. So this doesn't imply Z1 0 and Z2 0. Is it fine? And we have example. So for example, so you will be careful for complex numbers. So simple example I am taking. If you take 1 plus iota, I have actually number of examples. So the simple one I am taking 1 plus iota, 1 minus iota. Okay. So what I want is Z1 square will be, I am saying that I have two numbers Z1, Z2. Their square sum is 0. Square sum is 0, but both are non-zero numbers. Okay. So that will give us that will justify this thing, that in complex number, if square sum of squares of two numbers is 0, then it doesn't imply that both are 0. So I am giving you example. So example is Z1 is 1 plus iota. So Z1 square will be plus iota whole square. So this will be 1 square plus iota square. So plus iota square means minus 1 plus 2ab. So ultimately you are getting only, this will get cancels. Fine. 1 minus iota square will be, so Z2 square is 1 minus iota whole square. So 1 again minus 1 minus 2 iota. Now just check. Now Z1 square plus Z2 square should be equal to 0 now. If we are giving this example, it should be 0. So 2 iota whole square plus minus 2 iota whole square. This will be minus 4 because iota square is minus 1. What about this?
minus 2 iota ना, क्योंकि हमने स्क्वायर पहले ऊपर कर दिया है.
What?
Z1 स्क्वायर पहले कर लिया ना, 1 plus iota whole square.
हाँ, this is the Z1 square ना. And then what? No.
2 iota square, it will be only 2 iota.
Why? This is Z1. Z1, okay, sorry, very sorry, you are right. Otherwise, correct, sorry. So squaring is 2 iota and then minus 2 iota, but you can clearly see that Z1 is non-zero and Z2 is non-zero. So you will be careful. Sometimes you get such type of questions in IIT, you will check. You just go thoroughly that whether it is true or not, such properties you get. So in real numbers it is true, but in complex number it is not. We have example. So like for if I ask you, give me some other example, what you will do? You can multiply this by any constant, 2, 2, 3, 3, minus 1, minus half. You will get number of examples. Okay. So this example you can copy or you can write down. Okay, I think this is the normal size. I just try to now. Okay, now another property is this fine? I think earlier I was writing this was the font size when I started. Now I'll write in this font only. This implies clearly Z1 is 0 or in real numbers also we have this now, but this property is similar now, but this property was not similar. So you can note down. So now next thing is mod. Yes, modulus. It's fine now. Okay. So for modulus, what do you know for a real number? For real number, you are very much familiar how we define mod x minus x for x less than equal to 0 and x for x. If x is positive, mod x value will be x. If x is less equal to 0, for equality there is no difference. We can add equality here also, it hardly matters. So for negative numbers, mod x will be minus x. So it is what we know, mod x is always positive, okay. But in complex numbers, mod z, how we define, so mod z basically, suppose let z, I think always z is a complex number of this form. So mod in complex number, how we define, square root of real part whole square plus imaginary part whole square. So this will be under the root a square plus b square. If I just draw the diagram, then it will be mod x graph, everybody knows, very standard one na, how we draw, yes, V shape. One more thing, mod x is continuous, mod x is not differentiable, that you know very well. You have studied na, differentiability, continuity, that part is done, fine. So mod x is continuous, but mod x is not differentiable. Same thing is mod z is continuous, means that there is no break in the graph of mod z, but it is not, same thing. Actually in complex numbers, it's not that the same way we can draw the pictures. We cannot draw the pictures like this. Like in real numbers we draw na, we have curve tracing, we have formulas and all. For complex numbers, this way we cannot draw. We don't have like this pattern for the complex numbers, okay. So this you can copy. So mod z definition is basically under the root real part whole square plus imaginary part. This is simple. A and B are real numbers. Can they be complex numbers also? Real numbers, fine. And you know that for mod x, this is the point where the function is minimum. Mod x is minimum at x equal to 0. This part is not there for you people. So mod z is continuous. It's the same definition. What we have in real numbers, we have in complex numbers also. But mod x, we only the difference is mod x we calculate in real numbers by this definition, but in complex number definition is totally different. It is basically real part whole square plus imaginary part whole square. There is a difference na. Here mod x is defined like this, but in complex numbers this is defined like real part whole square plus imaginary part whole square. Is this fine? Any questions till now? Okay, now next thing is, now I am telling you how we basically draw or see the any number or any point in the complex plane. How we draw rectangle or triangle or square. So can I rub the board? This thing I think is something, C basically complex number set is basically similar to real number R2 plane, you know na, R2 plane. So C is basically similar to R2. You can see because Z is basically A plus iota B. We have real part, we have imaginary part. In R2 also, how we write the number? How we write any number in R2? In R2 we always write the numbers like this. So in Z also we have this form na. Here the only difference is this is x axis, this is y axis. Here this is real axis part and this is imaginary. So C is basically similar to what? R2. Okay. So whatever we study in R2 na, that goes for Z also, for the complex numbers. So all the properties of R2 are similar to complex number set. So in R2 how you draw? If I ask you draw the point xy, you can easily draw. Suppose this is x, this is y. So how you will draw? This is xy now. If I ask you minus xy, easily you can draw. Minus x minus y, easily you can draw. X minus y, easily you can draw. The only difference is this is this is x axis and this is y axis. Now draw. Now I am just take 4 points I am taking, and 4 points are like plus minus 1 plus minus iota. How many points are there? 4 points. One is 1 plus iota, another one is 1 minus iota, minus 1 plus iota, then minus 1 minus iota. Now draw the points in the complex plane. Only difference is this is now real axis and this is imaginary axis. How we draw now? Just iota just leave. This is 1 point. Okay, so 1 point will come. This is 1, this is 1. So 1 point will be, is this okay? 1 minus 1 point will be 1 positive. So 1, yes, fourth quadrant. So this is 1 minus 1 point. Now, yes, second. So this is minus 1. So minus 1, 1, and this is minus 1 minus 1. Fine. Is this okay? So for the argument, you just you got to know how we draw any point on in the complex plane. Easy, very easy. All the 4 quadrants you got to know. Now next thing is, yes. Okay, mod set actually this part is not there. I can explain, but this is not of their level. If they want, I can show the differentiability and everything, but that is not part of that. Just tell her that she can contact, she or he can, she can contact me through mail, or I'll send her, I'll tell her. Fine. I have the proof, but that is not in the syllabus part actually. I know how to do it. Okay, now you got to know how we draw the 4 points. First quadrant, second quadrant, third quadrant, fourth quadrant. So next thing is, first we learn the properties of complex numbers. Just write down few properties, very important properties. Now let's z as a plus iota b. So z bar will be a minus, I told you how to write conjugate, just replace the iota by minus iota. What will be a conjugate of z bar? Z bar will be, this becomes a property now. If you take the double conjugate, then you get the same number. Fine. So this is how we get all those properties. So very first property is this one. So z bar is z, very easy to see. Is this okay? If you take the double conjugate, you get the same number. Second property is, this is star one, you use a lot. This property you use a lot in the solving problems. So z plus z bar. So a plus iota b, if you add, this is iota b. What you are getting? 2a. It means this is twice real part of z. Twice real part z. From here only I am deriving one major property and useful property, that is basically if you have if you have a complex number, no, that's not the complex number which is purely imaginary. This is star one actually. I'll use this, you will use it when you solve the question, which is purely imaginary. So purely imaginary means what? Purely imaginary connect to real part. Real part is 0. Fine. So real part 0 means this is 0. So from this property you are getting z is equal to minus z bar. So in question, suppose you are given that this number is purely imaginary, which property you will use? This one. So what you will do, you will whatever number you have now, you will equate that to minus z bar, and you will get the solution and whatever required in the solution of the question. Is this okay? So if you have that the complex number is purely imaginary, it means real part is 0. So from this property what we are getting, z is equal to minus z bar. Okay. So this implies real of z is 0. So this implies z plus z bar is 0. So this implies z is equal to, is this fine? So next property, come to the next property, again important one. So z minus z bar will be what then? Quickly you can calculate z minus z bar. It will be a plus iota b.
Twice of imaginary.
Yes, twice of,
Imaginary part.
twice of, can I write it directly now? Twice of imaginary z. Now if you have your complex number which doesn't have imaginary part, you have na, and those numbers are basically real numbers. If they don't have complex number, then it means, oh sorry, if they don't have imaginary part, it means that imaginary part is 0. It means that if the number is purely real, imaginary part will be 0, and in that case you will z bar property you will use. Okay. So if the number, if the complex number is purely imaginary, oh sorry, purely I shouldn't have written, if the complex number is real, it means this implies imaginary z is 0, and this implies z minus z bar 0, this implies z is equal to z bar. Fine, easy properties, but now you are connecting this with this thing, this is extra one. Only you get this property in the like books and all, but you can relate the property to this thing easily. Next. Yes, tell me. First one, from fine. Any example you just take. Just give me any, for this one you are asking me, na, give me any number which is purely imaginary. 6 iota, okay, we can take it. Then what I am saying, that z will be equal to minus z bar. So z is this, z bar is minus of minus z bar is, whatever I am writing, that is basically true in general. It is not true like for like some particular cases. It means that for every z you will get this result. So you are asking me any question, any example, na? Any one number you are asking me. We have like all complex numbers will satisfy this. All complex numbers. So this is very simple one. You took, you can take any. Is it fine? So if I am writing any property, it means that that is true in general. Yes, in all cases. That is why I am not giving you any example, because every example will fit here. Every example will fit here. But I will not take the complicated example to check my property. You can take and you can do that at home. Is this fine? You want me to check this one also? It's simple one now. Because you will take the real part, and real part will be, there is no conjugate, so z is equal to z bar. 6 is equal to 6. Fine? Can I rub the board? Move to the next property now, and that is basically sum conjugate. Two numbers addition conjugate. It will be basically, you separate the conjugate and you add. Fine. This is also simple one. Fifth one is subtraction conjugate. Two numbers subtraction conjugate. It will be bar minus. It means this is also true in for any two complex numbers. For any two complex numbers, this will be true. Don't say that, ma'am, give me example. Any example will fit here. Any example will fit here. Fine. So sixth one is now for the product. For the product also, you just take the separate conjugate and you multiply. Okay. And now for the division, that is also simple one. You just take for the division, what you will do, you will take the conjugate and you will divide. And here what you will do, you will not rationalize, you will take the conjugate to remove the iota from the denominator. Okay, if you will get this type of question. And the last one is mod z basically is always equal to conjugate mod. Okay, and how you mod z definition I have given you, it was if z was a plus iota b, so mod z bar is also defined like this. Okay, so mod z we have defined. Now the last one, important one, mod z square is basically mod z bar. This also we use, you can verify. Fine. So these are this is all about the properties. If you want any question, if you have, you can ask me. Property means in general these results hold, and you can learn and you can verify also. If you will say I can verify any of the property, because you don't here in this class you don't need any proof. You do the proofs in the BSc Maths honors. If you do honors, you do all the proofs. Not by taking the examples, by the proof in general you prove the properties. Is it okay till here? Any questions? No questions? So now what I am doing is, because I have told you all the properties of conjugates na, so I am taking two examples. You just tell me how to do that. Okay, how to basically get the idea to solve the question. So very first question is, if x plus iota y is a plus iota b upon c plus iota d, prove that x square plus y square whole square is, I am giving you hint because this question I am taking, yes, I am just taking just after conjugates. After that, so you will do the mixed questions. It's not that you will easily get to know that whether this is conjugate question or what topic question it is. So because you have x plus iota y and you are supposed to prove something x square plus a square. So it means that you just relate it to conjugate. So for the solution or for the proof you can say, yes, good. So you have this. Is it fine to all of you? Fine. So take, I think I just square first. So squaring on both sides, what you are getting? Plus iota y. I am just squaring right now. So this will be, this is basically the squaring. Now what I will do? I just take the, yes, let me write the conjugate. Taking conjugate, if we are taking conjugate, then it will be, now take conjugate of this one. Okay, it will be easy. So take conjugate of 1. So it will be x minus iota y whole square a minus iota b upon c minus iota d. Now you can easily, this is a plus b, a minus b, and we need a square plus b square, and you know that when we will multiply this, then only we will get. So RHS with RHS and LHS with LHS we will multiply. So multiply 1 and 2, multiply 1 and 2, we get I can combine also na, if powers are same, power same na, so I can combine. Okay, and this side a plus iota b upon c plus iota d, a minus iota b upon c minus iota d. So a plus b, a minus b, a square, and minus we will get, but because of iota square it will become positive. Then a plus b, a minus b. For this question I have only one solution, but for the later questions now I have two solutions. Whichever method you find comfortable, I can suggest you, like you can go by this method or you can go by that method, because it's all about mind. Is it okay? The question was simple one. I am taking a different question. You people will suggest me how to do it. Okay, now can I rub the board? All have copied? So the next question is, this is also simple one. I think let me take this question first. If z plus z cube is 0, then I am giving you options also. I will give you 1 minute time to think, to answer. It means that you can start solving the question, because first I am giving you 1 minute, or I think you can say 2, 3, half minute I should give you. Which option is perfect one for this question? Z plus Z cube is 0. It means that you have to put a condition on Z. In this case, which condition is basically true for this statement? Your first move is for the solution. It means that in general you have to answer. It means this is Z, fine. 3 roots you will get, obviously. This is polynomial of order 3. So 3 roots, all the 3 roots should satisfy any one answer, fine. So how you are moving? Z plus Z cube is 0 given. You can take out Z common, fine. What does it mean? Which property we will apply? Z1 Z2 0. So means, yes, Z1 0. From here though I am getting that real Z is, but imaginary Z also 0, है ना? ठीक है? So Z1 0, and from here Z square is minus 1, so Z is, now you can tell me, I think. Combining all the 3 answers, what we can conclude? Here real part is? Real part is? Real part is? See the answers, then you decide. No, real part here, we don't have real part here. So real part is? Here real part was 0, but imaginary part was also 0. So this was not giving us like the perfect answer, but if we combine all the 3, what we are getting? C. Is this okay? So it means that seeing all the 3 solutions, you will come to a conclusion and you will decide which option is the perfect one. Is it okay? Easy? From here though what we were getting, imaginary Z also 0. It means that you just see all the answers. Then you come to a conclusion. So C part is the option. Now move to another question. Now let's see who will tell me how to move for this question. So I am given W is equal to alpha plus iota beta and beta not equal to 0. I am just circling it because this is important one. Beta not equal to 0. Any idea how this will help us? If beta is non-zero, no, it is non-zero. Yes, it means real part there is no condition. So, okay, let me come to the I think question now. Then when it will come, Z is x plus iota y. What we are, what basically the question is, if W minus W bar Z upon 1 minus Z is a real number, Z is not equal to 1, we are asked what is the locus. Locus, you all have studied locus in 2D. Path basically in this question, it is asking that what will be the locus of the points. Now the thing is, this number, this is basically a complex number, okay, is a real number. So to come to the locus, which property I apply? Real number, just see the property. If we have a complete real number, then fine, imaginary part is 0, then Z is equal to, no, Z is equal to, so simply I can apply, I can solve and I can come to a conclusion. Is it okay? You can see the which property? Third property I think. That is third or second? second property, in second property it is clearly given that if you have a number which is completely real, then z is equal to z bar. Okay, so I am applying that. So by, I don't know which property, by property third, we get w minus w bar z upon 1 minus z. So z bar is the conjugate of this. This is rational number. So how we take? I just take step by step. So conjugate of this, conjugate of this, a conjugate of this means separate conjugate. Is this okay? Negation also side by side. Is this okay? So this will be w bar minus wz bar upon 1 minus z bar. Okay. Simplify it, cross multiply. So what we will get? Cross multiply and come to a conclusion. So w, if you will, so basically what we have, w bar minus z, 1 minus z, w bar minus wz bar upon 1 minus this we are having na. Okay, cross multiply. So w minus wz bar minus w bar z plus w bar, and carefully because this bar is very important. So w bar minus w bar z minus wz bar plus wz z bar. Which terms are getting cancelled? This one with this one with this. So we are left with w plus w bar zz bar and then plus. Now the thing is that beta, you I think should take care of all these things. If something is given to you na, that has some meaning for the when you are simplifying the question. And how it has meaning? When you will simplify it, at the end what you will get? You can take out w common. If you will ask that question, it will be fine, but what I am doing, I am just doing the fractions, or I am taking common according to my convenience. If you will, now just see, you just take this to the left. Is this okay? Factorization. I am doing the factorization. Fine. So what I am doing, I am just keeping 1 minus this is common. So ultimately you are getting factors as fine. Two numbers product 0 means either this is 0 or either this is 0 or this is 0. What about this now? And that beta will help us to get to know this answer now. Product of two complex numbers 0 means either the first one is 0 or the second one is 0. I want to know the locus of z. Fine. So it means my focus is this only. This is not my focus. So I want this to be 0 because from here only I can get the answer. Okay. So can you be very sure now w is not equal to w bar? If beta is non-zero, can we be very sure that w is not equal to w bar? She is saying no. We are very sure. Okay, she is sure now. Okay, let me finish. No, be sure na. Then only you will get to know that this beta, how this is important. Sometimes you feel like why this is written na. Because what do? We don't need this. We never even bother. We never even come to like, we never even inquire or just go into deep why we are cancelling this, why we are ignoring this stuff. We do it na because this is not of our use, leave it, keep it. But what's the reason behind that? So beta non-zero means this is basically imaginary part. So w and w bar will be, okay, I just take the example. What this equation is saying? This equation is saying imaginary part will always be there. Fine, take any w, w bar will be not same na, It means that if imaginary part is not 0, W will not be equal to W bar, and from here either this number will be 0 or this number will be 0, but this is non-zero. What does it mean? This will be 0 then. Okay. So this implies this is 0. So 1. Fine. So reason here you can write down W is not equal to W bar. Fine. So last, Z bar equal to 1. What? Z bar is? Simply we can multiply if you are not like getting the idea. What will be the multiplication? This is Z, this is Z bar. So this is, what is the locus? Circle. Circle. Circle has some properties. This is a special circle actually. This is equation of a circle. Yes, unit circle we call it, with center 0, 0 and center radius. I hope this question is clear to all of you. Real part we were having and we were just solving, and each and every term is very important. That's how you can go to the right answer. Is it okay? Can we move to the now next question? Okay, now I think just change the topic little bit, and the next topic is powers of iota. This such type of questions also you get in your exams. Okay, basically from complex numbers, na 3 to 4 questions always, every time you get 3 to 4 questions means like around 15 marks. So this has like lot of weightage, complex numbers. So powers of iota, you are very familiar, but little bit discussion. First is iota, first power, no change. Iota square will be -1, all knows. Iota cube is good. Iota 4 is iota 5, okay. Iota 6, carefully answer. Iota 7, fine. Iota 8, 1. This is important now. What like basically what analysis we will do from here? Can I rub that left side? What basically the analysis says, after if you have iota to the power a number which is multiple of 4, we are getting, this helps actually. So we got iota to the power 4n is 1, and easily now with the help of this we can calculate any number. Like if I ask you iota to the power 26, tell me. So it will be iota, it will be, no, just don't be in hurry. It will be equivalent to, because if iota to the power, you can break it like 24, this will be 1, so -1. Now if I can ask you iota to the power, even I don't know the answer, but be iota to the power 50 will be easy for all of you. So iota to the power, if you have any number in that is multiple of, power is multiple of 4, you will get 1. Okay, now one more analysis, that is if you are adding 1, 2, 3, 4 consecutive 4 powers of iota, you are getting what? This is iota -1 minus iota 1. So consecutive 4 powers, if you are adding, I am just writing in general, iota to the power 1, iota to the power square, iota to the power cube. If you are adding this 4 consecutive powers, what you are getting? 0. Fine. Can I generalize it? How I am generalizing it? At iota to the power n, 2n, 3n, 4n will be always 0. Which one? No, consecutive powers, like just take any value of 1, oh sorry, n. 1, 2 you are taking, so 2, then 4, oh sorry. Yes, 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 yes. You are right. I am just generalizing in a different way. So 5, 6, so it will be n plus 1, n plus 1 I think I can write. N, then n plus 1, very correct. I was writing a big statement. So this will always be 0. So if you are adding 4 consecutive powers, you will always get your answer as 0. Now based on this iota power, I have 2-3 questions, and the very first question is, calculate the sum iota to the power r, where r is varying from 1 to 2006. 1 to 2006. So what will be the answer? What will be the answer? You can answer me. Do it. Superb answer, girl. What's your answer? Your answer is, I think now you can calculate this sum easily. This, in this question, what you did? 4 pairs you are making, and then you are leaving those because the sum will be, the rest 3 girls got to know. Fine. So ultimately, I just open it first. If you start r from 1, fine. So first, then iota square, iota cube, iota 4, this will be first pair. The last pair will be 2005, and then 2006 will be only 2 terms you will get, and then before this you will get 2004, 3, and then 2, 2, 3, and then 1. So this will be the last sum. This will be 0, 0, 0. You will left with these 2 terms only. Iota to the power 2005. So iota to the power 2005 you can write as 4 iota, and then here also you break it square. So this is iota and this is fine. Now any sum you can calculate. Another method for this question is, this is basically GP. You can apply GP formula also. Sometimes that also helps. GP formula. So Oliter means another method. This is GP, and GP sum is basically A 1 minus r to the power n upon. If you will calculate this, you will get the answer. But in denominator, na, you will get iota, and you know how to remove that. It's up to you, because now you got to know this property, and this is simple. Sometimes this property, if this is, you are getting this sum very difficult by this formula, then you can apply this formula. It's basically for other questions also. No? It's not that only for complex numbers you are learning. You are just you can apply this somewhere else also. Is it okay? Fine. It's easy. So any sum you can calculate now. If it is 13, what will be the sum? Iota. Don't say that I, because we have iota. The name is iota now. It's not English alphabet. So you can calculate it. Fine. So such questions I'm not doing. Come to now. Okay. The next question is, you should learn all the techniques, that then in any question you can apply any of the technique, whichever you feel like convenient. Find the least positive number. Okay, I think before that I should take this question. The next question is, if n is an odd integer, and iota is under the root -1, fine. Then, nobody asked me where we apply complex numbers, because whatever we study, that should be useful also, na? It's not that just like that we are studying. Anyone? Is fine. Where we apply this imagination? In what she said? Oh yes, in daily life only, otherwise we don't study. If it is not useful, why we study? Like multiplication we study because we can easily calculate, like if you are going to a market, we can easily calculate like how much to pay. We know how to get the, how to subtract, discount, and we know each and every calculation, then only na. Where we apply? That's not use. Where, acha, okay, tell me where you get this under root minus 1? In real problem, have you seen this? Like today, it's too cold, na? You are feeling only, you are not like seeing anything, na? Okay, so we have mechanics, dynamics, we have lot of like waves we have, wave theory. In wave theory, we write the equation with circuits also we have. So in wave theory, na, what we do, our equation is of the form some real part and some imaginary which we cannot see. So for that imaginary part, what we do, we just calculate the amount, like light we cannot see. Then how we measure the light? We measure, na. So that's rough idea, and we just take that as imaginary part. So real plus imaginary, there this study starts. Okay, so that is, I think, too far to go now. Okay, now this is the question. If n is an odd integer, iota is this, then 1 plus iota to the power 6n, 1 minus iota to the power 6n. Here right now I am giving you one solution, and then when I'll start the polar form, na, I'll give you some different solution for this problem. I have two methods, but right now I can tell you only one method. Then I'll come to the polar form. The same question I'll start with. So options are 0, any suggestions from your side? -2, +2, and none of above. I go by polar form. So what will be the, how we start? Simplifying. Okay, how I am starting is, we just break this power. I can break it like this. Simple one. I can break it in cube also, but that will be difficult one. So don't go to cube, first go to square. Square formula is easy, na? Fine. So 3n, what will be this? 1 plus iota whole square, 1 square minus 1 plus 2 iota to the power 3n. This will be again 1 minus 1 plus 2 iota to the power 3n. So 2 iota whole power 3n, 2 iota power, oh sorry, this will be minus. So this is basically 2 iota whole power 3n, odd number. So odd number negative, so it will come out. What we are getting? Odd power, na, negative sign. Fine. So 0. I have another method also for this, for such type of terms, that we will do later on. Yes, this is 2i. This is odd power. You can easily calculate it. Now this is also in general, na. Don't say that for which n or some like what. You can simply put any n. You can simply put any n. If you are in doubt, first n will be 1, na. So 2i cube minus 2i cube will be 0. Then next will be 2. N is natural number, so n2 it means 6. That easily you can calculate. Every time you will get 0. There will be no n where the answer will differ, because in general I am writing that for every n this is what? Okay, yes. No, I was just like that for this general thing. So n is odd. So what values? Correct, girl. So it means that in general it is 2. Any odd number you will take, for every n odd, this will be 0 only. It is not that for 1 it is some other answer, and for 3 it is some other answer. So this is the answer. Move to the next question now, and that is simple one. I think you people will answer me quickly, because I have to start with amplitude and argument. Done? Be quick now to answer this question, and the question is, for this n plus iota to the power 4, you have to tell me the value of n, obviously a natural number, for which it is an integer. First I want to see your move, how you are like proceeding. So the term is n plus iota to the power 4, and you have to tell me the value of n for which it is an integer. This number will be an integer. Integer means iota should not be there. Iota should not be there. Integer value we want. Okay. So how you are proceeding, or how you are like first step is what? This is 4 power now. Tell me, speak. Okay, you are going with that. Anyone? How you are opening it first? Okay, this is how you are opening it. You are not applying binomial. That will be simple one. Suppose it is here, you have 6, 8, 10, then what you will do? So it's better to open it by binomial. Open it. So when you are opening it by binomial, yes, NC0, first will be 4C0 n power 4, then 4C1 n power cube iota 1, 4C2 n square iota square, 4C3 n only n iota cube plus 4C4 n 0 iota 4. Quickly calculated. So it will be n4 plus 4n cube iota plus 6n square minus 1, 4n minus iota, and then this will be 1, as we know that this is multiple of 4. So finally this is you are getting. Just check the equation. N is natural number, so the value should be because I want to cancel these terms basically. So n will be, quickly tell me, I want to cancel these terms. So n should be 1. We will get the integer term, fine, every time. So n is 1, easy. So what you were doing, you were applying, that was not wrong actually, but suppose you are learning a method, then it should be general kind of learning. General means that if you are having 6 power, then it's not 2, 2, 2 and then you will multiply. That will be, I think, lengthy. If you are opening square here, 3 times you are opening the square and then you are multiplying, it will be too lengthy. Suppose the power is 10, can't do it. Because in 10, if you open it by binomial, 11 terms you will get. And then that's easy to actually figure out what value should we take for n. Is it okay? So that's simple one, n is 1. Can we move to the next topic now? Because so many things we have to learn. Okay, now come to modulus. Can I rub the board? Now we'll be fast because modulus you already know. So for the modulus, I have already told you mod z. You know how to define mod z. Which property is important? That also. If it is mod and it is square root, then it will always be and greater than equal to 0. Fine. When it will be 0? Quickly tell me. When a complex number is 0? Yes, tell me. Both are 0? Yes. First property? Fine. So first property is mod z is 0 if and only if z is, this becomes a property and you easily figure it out actually. This is called property. This already I have told you that mod z is always equal to, this you already have checked also. The next one is product modulus will be, you take the modulus separately and you multiply. The fourth one will be obviously division, and in division also take the separate mod and divide. Now the fifth one, that also I have already told you, mod z square is also equal to zz bar. We used it also. Okay, now the sixth one, first I'll ask you which property is this, because you are very much familiar with this property. Which property it is? There is a special name for this property in real numbers. Which one? No. No, 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 no. That is for equality. If you are talking about. No. Oh my god. Some T, T. It starts with T. It starts with T. This is rare one, which one I am writing, but for your learning. This is triangle inequality. Sum of two sides is always greater than the third one. Then only we can draw a triangle. Na? So this is basically, this has a special name, triangle inequality. I don't know which properties you were telling. Commutativity is basically this. This is commutativity. And I know Z is a field basically. Z is field means commutative, associative, identity, inverse, then commutativity, then this is with respect to plus, with respect to multiplication, it holds. It holds good. But this is basically, this is simple one. You can easily check. It's okay. These are the properties. Now come to, there is one more property also, parallelogram. And these properties holds in general. So don't ask me like, ma'am, tell me what are the numbers. Okay. But actually you got to know that if something is written, that is for in general it holds. Okay. So these are the properties. One question I am taking on this, because not like many questions you get on this. So given mod of z minus alpha 1 minus alpha bar z, here also mod alpha is not equal to 1 we are given, fine, and we are asked to find out mod z. How to move now? Basically modulus we are given, na, modulus of a number is equal to 1, mod alpha not equal to 1, that also is very special one. We will obviously use it, and we are asked to find out mod z. How will get mod z? Which property? Tell me. Z minus alpha 1 minus alpha bar z. Which property I apply? Fourth one. Okay. Can I do the squaring also? Can I do the squaring also if I just now start with this? Yes, both are same actually. We will apply both side by side. So I can write it squaring on both sides. What we will get? Square of this, square of this. So mod z square will be, I have removed this actually, this fractional. What I have taken, what I have done, I have taken the mod to another side, and obviously by this property. You will not say that I haven't used this property. This property says that mod of rational number is mod of this upon mod of this. Fine, that is already I have used, and then I have taken that this mod to this side. Is it okay? So fourth one is already used. So you were right that fourth first we will use, and then which property to use? Mod z square zz bar. So squaring on both sides, what we will get? Squaring on both sides, we will get the square. So this is z minus alpha whole square 1 minus alpha bar z whole square. Is it okay? So squaring means this zz bar 1 minus this, and then conjugate of this. Is this okay? Here the thing is, this alpha is nothing we are given. Only we are just given mod alpha is not equal to 1. So it is not that alpha is a real number. We will take conjugate of alpha also. Okay. So when we will open this is subtraction conjugate na. So it will be separate. Fine. So z minus alpha, z bar minus alpha bar. Is it okay? Because real number conjugate is basically a real number only. So this will be alpha bar to the bar will be alpha only, z bar. Quickly multiply. So when you will multiply, you will get z bar minus z alpha bar minus alpha z bar alpha bar, fine, and on RHS 1 minus alpha z bar minus alpha bar z. Is this okay till here? Our focus is mod z. Focus is, and mod z basically we have two definitions. First one is mod z square is z bar. Okay, so z bar we are getting, so we can think of that property only. So mod z square we got, because our focus is to calculate mod z and we are getting z bar also. So this I can write it like this. I can write it mod z whole square. So that's, and alpha bar will be mod alpha whole square. Now just cancel the terms if we can cancel. This is getting, and just change the rest terms. So this will be mod z square, and then this will be mod alpha square 1 plus mod alpha square mod z. Is this okay till here? And just keep this thing in mind. Mod alpha not equal to 1 means mod alpha minus 1 is, it means how I should factorize it. How I should factorize it? I should get one term as 1 minus mod alpha. Are you getting it? Because I have to factorize it na, easily I can factorize it. So one factor should be 1 minus mod alpha. So how I can factorize it? I am just taking this term and this term one side. Okay, mod z square will be common, then 1 minus mod alpha square. Is it okay? So this is how I am factorizing it. So mod z square minus mod alpha square, this term at one side and this term at one side. Is it okay? So the next step will be mod z square common. So 1 minus mod alpha whole square. Yes. So you got to know the use. The term which, if it is not given in the question na, then you cannot cancel it. It's a big question then, because we can cancel the non-zero number. Otherwise we cannot cancel. So each and everything given in the question is very important. This is by what? Okay, we were supposed to find out mod z only. So mod z is, why I am not writing minus 1? Anyone? Anyone? It will be, yes. So mod z is, sometimes we were given minus 1 option also, because we are very like in real numbers what we do, always we write like this, fine, but this is mod actually. It's okay till here? Good question. Okay, now move to this. I think this is also, and just after that I think, what's the time right now? So next question is, find the least positive integer value of I think I should do it after defining you the polar form, or I think you can learn this method also, and for which 1 plus iota upon 1 minus iota whole power n is real. We have to calculate the least positive integer value of n. Fine, least and positive also, that this becomes real. Fine. So for this solution, because iota is in denominator, so first we remove this. So 1 plus iota, yes, 1 plus iota, 1 plus iota whole power n, inside I am doing it. So 1 plus iota whole power whole square will be 2 iota only, now you know it, and this will be 2 only, it will be 2. So iota to the power n, I am asked that this number should be real. So it means what should be the least positive integer value of n? For if I am taking n1, it will be iota. If I am taking 2, it will be minus 1. So least value becomes 2. Why 4 you said? That is integer, na? And real also. Focus is that n should be positive integer and that value should be real. So for n2 you are getting this value as minus 1, that is real number, and n should be positive and integer. So least value of n will be 2 only. Okay. So our focus is that this should be real, that and we are supposed to find out. Is it okay? Positive? So this question is also done. Now move to, I think now we come to argument and the main important topic. Can I rub the board? Okay. Any questions till now? She is copying. No questions? Nothing coming to your mind? No, questions. What's the question? Ma'am, what will be the answer for? 2016 to the power 2016. Is this correct? Just ask Amrit. This is, I think this. Just ask her if she is asking this question. But this is not, I have to see this because complex number and 2000 to the power 16. Let me see, because there is no complex number inside. Real to the power real she is asking me, na? I am connecting complex numbers. I am doing the complex numbers part. And you just give her the mail ID, my mail ID, if this is the question. Can I rub the board now? Because this is something real, connected to real. She is not asking me a complex number part. And I can suggest when I'll come to the cube roots or nth roots, then I can suggest her. It's not that I don't have solution, but I don't know whether you know that thing or not. Okay, now come to argument, or another name is amplitude. This is the most important part in complex numbers. So Z, basically we are using the notation Z, A plus iota B, fine. So what is argument, what is amplitude? Both are the same thing. So first you draw this point, and this in R2 we call the plane as 2D plane, na? In complex number we call this plane as Argand plane. Yes, this is the name. So this is real, this is imaginary. Where this AB point will be? This is A, this is B, this is the point. So argument is basically, argument of Z, this is the notation, is basically angle. And which angle is basically this? This is important. So this is the angle and this is the radius vector. It means that this radius vector, this was the point, na? This was the point, okay, and from origin to this point we have drawn one line, this line is called radius vector. The angle which this radius vector makes with this x-axis, na, that is called argument, okay, of that point, Another definition for this is theta is basically we calculate as tan inverse mod of b by a. Is it okay? Here the thing is that if this theta is the argument, na, of any point, then it doesn't mean that we have only one argument. We have number of arguments, because if theta is the argument and if we add this number to the this even multiple of pi, then again you will get another angle. So if 60 is the angle, then 2 pi plus 60, then 4 pi, then 6 pi, even multiples of pi. Fine? Yes, even multiples. I am taking 2n. Even multiples of pi, adding the angle will again be a argument. So it means that for a point, how many arguments we have? Infinitely many. There is no counting. N belongs to n, natural numbers. So this is how we calculate. Let's start with first question. And the question is, now I am telling you what I am doing. I am just taking all the 4 points, in 1 point in each corner, and I am telling you how to calculate the angle. Is it okay? Because any complex number can be in any of the quadrant. I am telling you how, if the complex number in first quadrant, how to calculate the angle, in second, in third and fourth. That will suffice. That will be complete answer. So I am taking find the argument of first question, and the first question is, okay, before this can we do the properties also? I think just properties. First we take the properties. So very first property for the argument is argument of any number plus argument of the conjugate of that number will always be 0. It means that 1 plus iota, 1 minus iota argument sum will be 0. Okay. So this is the property. You will take the help of this property. Then argument of division. If you have two numbers in division form, then argument, how you will calculate? The first number argument you will subtract, fine, from the first one you will subtract the another argument, and I am telling you how to calculate the argument, just understand the properties first. Then come to product. For the product, simply you add the arguments, you will get the answer. It means that if you have two numbers in product and you are asked to find out the argument, what you will do? You will separately take the argument of the first one for the second one and you will add, and I will tell you Abhi right now how to calculate argument of any number. Fine, then you can easily add. Now if you have power, power means z to the power some power, okay. So in that case argument will be this, oh sorry, the formula will be this. You will take the n, like in log we do na, log nm is m log n, m log n, and the thing is that this angle is in positive direction. Yes, this is important. Positive, you cannot go down. You cannot go down. You will take the angle from to the positive direction. Can we start with the question now? Tell me.
Positive least value to
For which one?
last question. Positive. I have to the
2 was also positive. How can I connect to that, Amrit? How I speak to her? Iota. N is 2, fine, n is 2 and we want the least value, fine, the smallest value. So 1, yes, n1 was not was not the correct answer, because for n1 we were getting iota, okay. For 2 we were getting -1, and for -1 is a real number. Yes, we need n to be positive. Amrit, if you are listening me, n should be positive and the number like the complex number which we were given, that should be real value. So iota power square is -1 and -1 is a real number. Okay, -1 is a real number and n is a positive number, na? So we are not violating the condition. Is it okay? Iota to the power 4 is 1, again a real number, but we want the least value. So least value will be what? 2 or 4? 2. So n is 2. Okay. If again she has problem, so is it okay till here? Basically you can compare the argument basically by log. Log formulas are same, na? Log mn is log m plus log n. Log m by n is log m minus log n. Log this is something different. So log mn is n log m. So argument property is basically similar to log properties. If you forgot, you can memorize the log properties because that is simple one. Is this okay? Can we take the question? And for the question, I am just taking each and every quadrant. So the very first question is, I am taking each and every quadrant, so it means I am taking all the points. So what are the points? First is this. In second quadrant, which point we will get? In second? Yes. In third? Good. Then we can draw also, all of you. You can draw the points now. So the point will be, draw the points. Keep that in your mind that from x-axis to the positive direction and to the radius vector, that angle we have to calculate. Okay, from this line onwards. From this line we will calculate the angle. So first point is 1 under root 3, somewhere here. Roughly I can draw -1 under root 3 here. Then this is -1 minus under root 3. This is 1. All the points I have drawn now. What is the radius vector? Okay. On x-axis our focus is with x-axis. Fine. So for this, the radius vector will be this one. Can you draw for this one? This is the point, na? This one basically focuses x-axis only. For this one, opposite, and for this is it fine? Drawing, because sometimes you get confused, I draw the line here or here, but basically the angle should be with the x-axis. It means that radius vector should touch. Fine. Is it okay till here? Start with this. Our formula for this argument is argument of first point. So 1 plus under root 3 iota. So theta basically tan inverse b by, yani under root 3, where this value 60 degree or pi by, first angle we got to know, this is pi by 3 and this is perfect one because this is with the x-axis. So argument of this point is pi by 3. Fine, there is no problem at all. But now come to this. Actually, when where I wrote the formula this, did I write mod also? I have written mod, na? Then fine. So now come to this point. Angle will be again same. How much? Pi by 3. Yes. I am taking it. It's not the argument. I am coming to the answer. This angle we are getting, but this is not with x-axis. So our radius vector is this one, and this is x-axis. So which angle I want? This one. So this is pi by 3. Complete is pi. So for argument of -1 plus under root 3 iota will be, so this is one answer, na? Can I add 2 and pi for many answers? Is it okay? So many answers we are giving for 1 point. Now come to this. Again the angle will be, this is special one. Okay, now before coming to this, just come to this point first, the fourth one. The angle is, this is basically we want to go to the positive direction, fine. But this angle is in negative direction. So for negative direction what we do, simply we just put the minus sign. Is it okay? So third one is this is basically the last one. So plus argument of this is minus pi by 3 plus 2n pi. Is it okay? Which one? Okay, for this I think she is talking. So now for come to this point, this is I think something you should. Now this is pi by 3 na. We can like move pi plus pi by 3 we can go. So answer will be 4 pi by 3, fine. But basically na, here I just write one principal argument. I just add one point, that is actually generally important thing. So principal argument basically means that we basically want the angle between 0 to 2 pi or minus pi to plus pi. Basically whenever we calculate argument na, we keep our answers between these limits. We keep our answer between these limits only. Basically the thing is here, this is pi by 3, got to know. The complete angle with this radius vector, this is the radius vector, this is the x-axis, so complete angle should be pi plus pi by 3, 4 pi by 3 answer for this this point. So 4 pi by 3 plus 2n pi, that is the answer, not wrong, fine. But that answer is not coming in principal argument. Okay, sometimes generally we are asked. So for principal argument what we do, we just now going in a different way. This is 0, this is minus pi. If we are going in negative direction, minus pi. So this is minus pi na. So what I do, minus pi plus pi by 3. How much it will be? Minus. For the point argument of minus 1 minus under root 3 minus pi plus pi by 3. So what I am getting? So this is between these limits. So this is the principal argument. Is it okay? So 4 pi by 3 plus 2n pi was not the wrong answer. What was the issue? That was not in the principal argument. And every time what we need, we are asked actually that calculate the argument in principal limits. Is it okay? Got to know all the 4 quadrants. Now for any, I think for any point you can easily calculate the, because point will be either in first, second, third or fourth, nowhere else. And you know how to calculate the argument. Quickly copy. Now I am writing one question, you people will answer me, even I will help. Just to confuse you, I will give you like 4 options and you tell me which options or what options or which option is correct one. Have you copied? Any questions? Easy? So now for the same question, I am giving you, no, not for the same question. Can you tell me the argument of this quickly? Quickly. In which quadrant it is? Fourth one, so quick answer. Minus pi by 4 because negative direction. Okay, easy. So but this is not the question to discuss. The question is argument of minus 1 minus under root 3. You have calculated this argument, fine. I am giving you options now, you tell me which option is correct one. So first option is this, second is, quickly calculate the answer, even we have done the calculation basically. And for the argument, this will be the last question because in each and every quadrant I have told you how to find out the answer. So quickly calculate what basically the normal or the basic answer which you are getting for the argument is Just in the last question we have calculated, na? What was the answer? Just take the different one, because in option you can see that. So the other option was 2n pi plus 4 pi by 3. Fine. So what options basically are correct? This one. If you take n2, you are getting it. What about this one now? This is something basically, if you can write it as minus 10 pi plus pi. So for n minus how much? Minus 5, because n is an integer value we can take here. N is basically for this one, please an integer you just mark, because negative values also we calculate. So you can write it as minus 10 pi. Yes, I can repeat, because this is pi by 3 na, and we just want to check which options are correct. Fine. So 4 pi by 3, 2n pi. This is some negative, and near to, because we can put here integer value, negative or positive. Just a moment back we did it, na? Don't take the principal argument, because this is in general. So they have written 4 pi by 3, so pi by 3 plus pi. So that angle basically is given in the options. Not getting? It is a problem to everyone? Rest are getting the idea or not? Okay. This was in the third quadrant, na, this point. So in the third quadrant, this was the radius vector, pi by 3. Just see the girl here. Pi by 3, and then, so what basically this radius vector with the x-axis, how much, what angle it is making? Pi plus pi by 3. That time I was telling you pi plus 4 pi by 3 plus 2n pi is not a wrong answer, but if we want the answer in principal argument, then what we have to do? We have to reduce the value na, to come to the interval. No, nothing, because options we are given. Nothing is written that in a principal argument you have to see the answer. You are given the options, and this is one of the options. So pi plus pi by 3 yani 4 pi by 3. So basically this is the answer. Now I am just checking what options or what parts are, basically one part is true or two, or like no one. It cannot be like no one. So this part is okay, because for n2 it is, we are getting this option. Now coming to this point na, this is also basically I can connect to this yes, what I can write, n I can take as minus 5. So minus 10 pi, minus 10 pi, how can I write minus 9 pi? Minus 10 pi plus pi by 3. Okay, so this becomes minus 10 pi, pi plus pi by 3, 4 pi by 3. It means that this option can be written like this also. Fine. Now what about this? There is no point, because it can never be odd number, because 2n. Every time we will get a even number. It cannot be odd number. So this is wrong, this is wrong, this is correct, this is correct. So it means that you have to see the options very carefully. In one look, though, it is like that this is not the option. In one look you can say na, this is not the option. But when we do the calculation and we see, this is also one of the answers. Done argument part. Okay. Now let me come to the, because of the time boundation, square root of any complex number. So square root of, any questions? I think now you are comfortable with the amplitude or argument. Any point, from my side I am like that you can calculate now. For any number you can calculate. Which one? Okay, who is asking now? Sandeep. Boys are there? Okay. So which one? The second part? Can you please explain it? Okay. Can I explain it with this part now? So for this part, this is minus 9 pi plus pi by 3. So what I am doing, I am just checking whether this is somehow, if I substitute any value of n, and any, if I am getting this, so what I am doing, I am putting n as minus 5 in this value. So what I am getting, minus 10 pi plus 4 pi by 3, and it can be written as, I can write it as minus pi, minus minus 10 pi plus pi by 3. I can easily break it, pi plus pi by 3. So this becomes minus 9 pi plus pi by 3. So this is the second option. Easily I can write it. So it means the second one is correct one. Is it okay? I hope it is okay to all of you. It is okay. I hope it is okay to him also. So square root of a complex number. This is actually, for this it is, we have a fixed method. Fixed means that you need to know the method, then only you can calculate, otherwise the calculation will be very difficult. So square root of any complex number, it means that you are asked to find out this for any complex number. I am taking a simple complex number, and that complex number is, let this is the number of which we are supposed to find. I should not write let, I should write calculate. So calculate this. Fine. How we will calculate it? So just let minus 7 minus 24 iota is equal to, it will be a complex number only, na? If we take the square root, or if we square, it will be a complex number, whether purely real or purely imaginary, we don't know right now. So this is okay. What next step should be? Squaring. So on squaring, both sides, we get, what we get? Minus 7 minus 24 iota x plus iota y whole square, open. So minus, now you can easily open. Can I write directly? How we compare the two complex numbers? Because two complex numbers are in equal form, so equating real with real and imaginary with imaginary. So 2xy, I am keeping it as it is. So two equations you are getting. Now after this, if you learn one formula, na, calculation will be very simple, and that formula is, yes. So we have x square plus y square whole square, we can write it as 4x square y square, or you can write like this. The same thing, okay. I am writing it at 2xy whole square because my terms are like this. Put the values. So this implies x square plus y square whole square will be minus 7 whole square plus, quickly calculate it. So you will get it. It will be 49 plus 576, ultimately, yes, 625. So it means x square plus y square will be, can I write it negative also? Why I am not writing negative? Yes, square and add will never be negative, okay. That is why I haven't written minus. So I have x square minus y square, this term minus 7, fine. So it means that you know it, x square plus y, x square minus y square I was having. Then to solve, because we need x and y, we need x and y to know the square root, because square root is equal to x plus iota y, na. If we know the values of x and y, we will get the answer. So main motto is to calculate x and y. So if we solve this gets cancelled. So 2x square will be 18. So x square will be 9, x will be, yes, this time I have written minus also, na, but that time I didn't write minus, and there is a reason behind that, okay. Now how to calculate y? What will be the value of y? Yes, in the second, this one. We can calculate here from here also, but I think second one is okay, na. So x is plus minus 3, y will be square root. We have to calculate under the root minus 7 minus 24 iota x plus iota y. We need x and y values, na. We need x and y values. Now we have how many combinations? 4. Which combination will will be perfect for our problem. Now you just see xy from here, xy is got to know easily. If one is positive, another one will be negative. So if x is 3, y will be, if x is, what to know the answer? These are the only two options which basically fit for our problem. Is it okay? These are the two options for our answer. So under the square root you got to know easily, or we do one more question? Okay, if you got to know, I think we should calculate under the root minus iota. Okay, quickly start doing it. Have you copied? Can I rub the board? All have copied? And please, you are most welcome for any question like others are asking. You are also, that's how you learn whether the question is stupid or good one, है ना? You should ask. So the question is under the root minus iota. Under the root minus iota. It means we are calculating minus iota to the power half. Minus iota to the power half we are calculating. So what we will assume? We will assume it as x plus iota y. Then squaring. So minus iota will be, on squaring we get x plus iota y whole square. Steps are same. I can be fast. So x square minus y square, equating the real and imaginary part. Equating the real and imaginary part, we get, what we get? What we get? X square minus y square as 0, 2xy as minus 1. Which formula again? The same formula. Can I rub this portion and I start from here? है ना? It is already written, no need to write it again. So this is the formula. Substitute the values. So 0 square plus minus 1 whole square. So 1. So x square plus y square value you are getting as? Again you are saying plus minus 1. Be careful please. Only 1. Okay. And we have x square minus y square as 0. How much? 2x square is 1. So x square is, x is plus minus. What will be the value of y? Yes, same values will get. It's fine for all of you? The same values we are getting. But again, how we come to know like what xy values we take? What values? Because xy product is negative, so one will be positive, other will be negative. So therefore, the answer is x will be, if x I am taking as plus, y will be negative. If x is negative, y will be positive. So these are the two options. Fine. Any question you will be able to do? At home you can try this question now. No. I think 2 questions are sufficient for this, because this is very standard one. You are not doing, you are not like using your mind. You are just learning the method and you can do it. So there is no calculation here for this. So you can try this at home. This has actually basically a difficult answer. That's why I am giving you. You can try it at home. The answer is x value is basically plus minus under the root, under root 2 plus 1 by 2, and same for y. You can note down the question. You can try it at home. So square root of any complex number is done. Now come to cube roots of unity. That is also interesting topic, very interesting actually in complex analysis, complex numbers. Can I rub? I think you all have copied. So the next is cube roots of unity. How this basically concept starts? Cube roots of unity. It means this thing. Cube roots of unity. Fine. But in which plane? Who said 3D? Let me know. Who said 3D? Okay. I compare the complex numbers with which plane? No. R2. 2D na? So why you said 3D? Fine. So cube roots of unity. This is a basically how many answers basically this question will have? 3. So how to how to know the answer? First, just consider the equation. This equation basically. Consider the simplest equation, a cube minus this basically this is x cube is equal to 1 na?
Yes, ma'am.
Okay, x cube 1. So how we come to know for this? Factorize it. A minus b, a square plus ab plus b square. Fine. So what answers we are getting? 1. Then from here how we get the roots of this equation? This is quadratic equation. So minus b plus minus under root 3 iota. Can I write directly? Because you are very you know the roots. So one root is this. Another is, you know this problem very well. This is 1. This is omega. This is omega square. If you square this number na, you will get this. Okay. Now just the property of this omega root. Now this omega is basically satisfying this equation. So it means one relation we are easily getting, 1 plus omega square 0. Okay. Omega cube, if you will calculate na, that will be 1 omega, because satisfy this equation also na. So omega cube is 1. So these two things basically very important, these two properties for cube roots. These are called cube roots of unity. These are called cube roots of unity. Cube roots of unity, and you will learn these two properties, very important one. Now if I ask you w to the power, okay, now just see in iota na, iota to the power multiple of 4 is always 1. Here multiple of, if the power is multiple of 3, it will be 1. So omega 6 will be omega 9, 12, easily calculate. Fine. If I ask you 1 upon omega, what value this will have? How to just, okay, very wrong. Just use omega cube. Okay. So what I'll do, I'll multiply this by, so omega square by omega cube. So it means that 1 upon omega is omega square. Okay. Now you can tell me 1 upon omega square easily. Be quick to answer. Omega. Okay. So with the help of these two properties, you can easily, fine. Now come to a question. How you said minus omega very quickly? Okay, she is just doing the analysis. बोलना चाह रहे होंगे. So this is third one. This is fourth one. If somebody said na, this is minus omega, this is basically a complex number. Okay. If you have, there is actually another property I am connecting with. This is omega na. So 1 upon omega, it will be basically 2 upon 1 minus 1 plus under root 3 iota. If you remove this iota na, ultimately this term will be basically equal to omega bar. Is it okay? When you will do the calculation na, you remove this iota, it will be equal to omega conjugate basically. So this is another property. So 1 upon omega you can write, if you in question, if you need omega square, it is helping, then you will write 1 upon omega as omega square. If omega bar is helping, then you will write it as omega bar. So these are two values of 1 upon omega. Can we move to the question now? Cube roots of unity, fine. Easily you got to know. One more thing, very particular one. In omega na, this the value is minus 1 plus under root 3 iota. So minus is here. You cannot say, sometimes basically we forget, and what we do, if we are asked now what is this value, you quickly you say this is omega. You always say. Sometimes it happen because this is similar to omega na. So in omega particular thing is minus 1 plus under root 3 omega, that term we are calling as omega. So if we want to make it as omega, we have to take out minus common. We will write it as, so this is basically not omega, this is minus omega. You will be careful. Omega value you got to know, like omega is this one only. It's not that every term 1 plus having 1 or under root 3, that will be omega. No, we have fixed this value. Is it okay? Chalo, move to now. The very first question which I am taking is, can I rub the board now, because board is, and you will keep the properties in your mind, then only you will be able to solve the questions. So very first question is, find the value of 2 plus omega square whole cube 1 plus omega square to the power 8, then 1 minus 3 omega plus omega square to the power 4. How we basically, we have two properties only, 1 plus omega square 0 and omega cube is 1, and with the help of this we can have idea for this for so many powers, like omega 4 will be omega 5 will be omega square. Okay, but how to start now? This is 2 now, I can break it as 1 plus 1. So 1 plus 1 plus omega square to the power, is it okay? Because 1 plus omega square will be 0. How to break it now? We cannot do it now. Tell me. Yes, we can write. Then it will be, yes, we can write it. Answer will be same. She is correct. Her mind is moving like that. Why we are not changing omega plus omega square? She is perfectly okay. But girl, this is 0 na ultimately. So 2 minus 1, 1 or 1 plus 0 is 1. So you can go that way also. There is no harm going. Yes, there are so many ways. So here also 1 plus omega I am changing. You can do like some other method you can apply. What you will do, minus omega square you can take to this side, then you can put the value. So it's all about, yes, 1 plus omega will be minus omega square now. So you can change minus omega square, you can change 1 plus omega. This is all about how your mind is working at that time. This is basically, this works like that. So 1 plus omega I can change, fine. So minus omega square minus omega square to the power 8. Then how you will change? 1 plus omega square. So 1 plus omega square will be, so there are so many methods. This becomes 1 only, 1 cube 1. This will be minus 2 omega square to the power 8, and this will be to the power 4. This will be how much? Because this is even power. So this will be 2 to the power 8 omega to the power 16. This is again even power. So it will be, just compare these two terms. Are they same? Are they same? Okay. Omega 16 will be what? Omega 16 will be, because omega 15 will be 1. Okay. You can break it as omega 15 into omega. This you can break as omega cube into omega. So 1 plus 2 to the power. Okay, now what I can do, I can just make it half na. So 2 to the power, can I write it again 4 to the power 4? I can write it na. So 4 to the power 4 omega minus 4 to the power 4 omega, it is basically ultimately 1, because these two terms are same and with negative only sign difference. Is it okay? So such questions you will be able to do, very simple actually, and big terms actually you get in your exam. So next question is, now you can suggest me any calculate, simplify, you have to simplify these questions. So the question is this, anybody, because I have trick with me, what trick you will suggest to me? You can easily suggest. The only motto is if anyhow these the numerator and denominator anyhow we can cancel, fine. So here we have omega square, fine. If I write this 1 as omega cube and I take out what common? Omega, fine. So omega if I take out common, this will become a, this will become b, and then c omega square. Getting the idea? So this is this is how you think. So a plus b omega plus c omega square, or you can make the changes here also. Here you can write omega cube and then how much to take out common? Omega square to make this term. Fine. So what I am doing, I am just writing this 1 as omega cube, take out omega common, c, take out omega. So a plus b omega plus c omega square, take out how much? Because I need omega square. So how much to take out common? Only omega. So c omega square plus a, both are the same now in numerator and denominator. So 1 upon omega, I have given you the answer also. And one more answer. But in options you will see whether omega square is given or omega bar is given. Okay. Okay, now move to the next question. Copied? So basically what you are noticing here, you just using the properties to simplify the problem. What properties you can apply, you just have to just come to a shorter method to solve the question, not the bigger. You just shortening the solution length. This is how I think in IIT, this is what you are learning, na? Just short the solution. Big method we are not learning. Quick answers and short methods. Can I rub? Okay. So the next question is, I am writing two questions side by side. So the question is, think on this question. Iota plus under root 3 by 2 to the power 100. Prove, you have to prove it that this is omega. This you are supposed to prove that this iota plus under root 3 by 2 the power 100 omega you will prove. Omega value will be what? Was what? Minus 1. It means that final answer should be of this form. 100% it should be of this form. Or if it is omega value was any property if we can apply, 1 by omega square was omega. Okay. So this is how we'll see that how we can move. So the thing is, very first thing is this iota is not with under root 3, but in our problem we want this with under root 3. So better to take out iota common, and if we are taking iota common, it means iota to the power. Actually we want answer to be in iota, omega, and in omega we have an iota with under root 3. So it means that we have to take out, first step should be we take out iota common. So iota to the power 100, and then this will be 1 plus under root 3 by iota to the power 100 2 also I just keep inside because 2 also I need upon 2. Is it fine? Iota to the power 100, quickly tell me. Multiple of 4 will be 1. Taking time. Yes, it will be 1. 25 fours are, so it is multiple of 4. So 1 plus 1 by iota also I have told you. It will be? Yes, minus iota by 2 till here fine. Okay, now 1 minus under root 3 iota by 2. What's the problem? This already I have told you. What's the problem with the, yes, sign only. So if I take out minus common, so minus 1 to the power 100 again, no issues. So positive. This is omega to the power, and omega to the power 100 is, because multiple of 3 will be 1, so 33 into 3 99, so we can separate it as omega 99 into omega, and that will be omega only. So this is omega 99 into omega, so this is 1 omega only. Is it fine? Easy? So how we see, like where we have to move, according to that we take the steps. It's not that randomly we just start taking the steps. We just see where we have to reach. Okay. So the next problem is question: if z is a complex number satisfying, now see for this problem also, satisfying the equation or the relation z square minus z plus 1. If z is a complex number satisfying the relation this, find z to the power 200, or any power you can calculate. I am taking 200 only. You can answer me for any power. So how to move? Z is a complex number satisfying this relation. It means that we have to take out z from here. Okay, so what will be the values of z? We know the formula. So formula is z square. It's the same in real we do. So z value will be minus b plus minus under root 3 by, here again a issue, and that issue is I am getting two values. One value is this and another is this. The issue is what? That I cannot use the omega thing here. I have to connect it omega na, because then it will be very simple, omega to the power something, and then only it will be simple. Can I compare it to omega? This is basically what? This thing. Just compare the two. I took out minus common na, but in this question, previous question, it was minus 1 to the power 100. So it minus anyhow get removed. Here we have to take out minus common, and that will be, we cannot remove this minus na. Fine. So this is also I was having omega square value as, omega square value was minus minus na. So I again multiply this by minus. Is this okay? So basically the roots of this equation are no, minus omega and minus omega square. You can see this is minus omega na, I took out minus, then this is omega, so minus omega and there is no power. Right now there is no power. I am not coming to this. First the thing is I am just calculating z, then I will substitute the value. Right now I am just calculating z, what values basically we have for z. So z values are minus omega square. Okay. So I can put here minus omega and minus omega square, answer will be same. Answer will be same. So what I am doing, I am just substituting minus omega. So if I substitute minus omega in instead of z, so this value will be now z to the power 200 plus z to the power, and you can check, like you are believing my words that for minus omega square values will be same na. So what you can do, you can put both the values and you can see the answer. if you are doubting, and you can easily calculate. So minus omega to the power 200 plus minus omega, I think you can easily answer me this. Will you calculate? Take a minute. Tell me. Okay. Quickly tell me. If any of the girl will answer, then I'll proceed. Omega square plus omega, and that is basically, we have a relation now. So we never keep minus 1. All got the answer? Very good. Minus omega square you can put and you can get the answer. So minus 1 to the power 200, then omega to the power 200, then from here also minus common, omega to the power 200. So this is again positive, and this value is, this is, if you are dividing it by 3, so you are getting how much? Oh sorry, 2. So omega square plus 1 upon this is, so omega square, and I have given you this value. And easy. Any question related to this, now you will be able to calculate, but you have to be very careful. You will not say that this is omega. You will see the value. Omega is very fixed now. Cube roots of unity are fixed. I think one more thing I have to tell you, because I have to move to the nth roots of unity. Done, this part is done. Now just notice one thing. This is the equation was, for cube roots of unity, equation was what? Remember the equation? Omega cube, x cube 1, x 1 to the power 1 by 3. This was the equation na. So roots were, this equation is basically x cube minus 1 equal to 0. Fine. 1 plus, roots of this equation are 1 omega, omega square. You know sum of the roots, product of the roots taken 2 at a time, and then 3 multiplication of the roots. You know how to calculate from this equation. So sum of the roots, basically how we write, minus b by a. So here we don't have b, because this equation is x cube plus 0x square plus 0x minus 1 equal to, so this is a, this is b, this is c, this is d. So sum of the roots is minus b by a, it means this is 0. Product of roots taken 2 at a time. So omega 2, if you are taking 2 at a time, it means omega cube and then omega square. Fine, 2 at a time you are taking. This will be what? C by a. So C by a will, again it will be 0. Then the last is product of the roots, and that is minus, C by a only, not negative, and d by a minus d by a, and that will be 1. Why I am telling you? Because I am moving to the nth roots of unity. It means it is not that only cube roots you are asked or square root you are asked. You can be asked like any power, 4th roots, 5th roots, 6th roots, and then some calculation or some question will be there based on the problem. Is it okay now? So how you will calculate, how this will be helpful now. So move to the next topic, and that is basically nth roots of unity. Can I move? So nth roots of unity, this is basically the last topic, you can say. So nth roots of unity. Nth roots means what? Z is equal to 1 to the power 1 by n. And here basically a different formula and very useful formula starts. How we write the solution now, you will learn it. This is basically I am teaching you de Moivre's theorem. You have studied the very important theorem in de Moivre's theorem. Wait a minute, I am just, this is the spelling, de Moivre's, M-O-I-V-R-E-S theorem. No, not De Morgan. Law, that is law basically. De Morgan has given a law, that is De Morgan's law. This is de Moivre's theorem, and how we connect. Already we have connected, but now here the use you will see. How you can write, okay, one more term I think side by side I can discuss. Polar and then de Moivre's theorem. Yes, I think I should connect. Wait a minute, I think before this I have to tell you polar form, then I connect to this nth roots. So come to the polar form now. It means what? Any complex number you can write in polar. Polar means cos r theta form. So any complex number, how you write in polar form or cos theta or sin theta form. So suppose you have this number, complex number. So polar form is basically mod of z cos theta plus iota sin theta, and this theta is basically yes, argument of the element. ठीक है? Mod z you already know. Mod z is basically what? Under the root. This is under root. Theta you can easily calculate. Theta will be tan inverse b by a, and you already know how to calculate that. For any complex number you know. I am just taking one example. Suppose I am asking you, take the problem this, -1 plus iota. Write this complex number in polar form. So polar form will be, mod of this will be under root 2, real part square plus imaginary part square under root. Then what is the theta here in this case? 3, no, take any angle now, right? I am not restricting to principal value, fine. 3 pi by 4 or the rest, the other value will be minus pi plus pi by 4. Then the principal argument, that will be minus pi plus, are you able to calculate or not? Because you have already started, -1 and plus iota. So this is the point. Wait a minute, this is this point, na? This is in this quadrant. So pi minus pi by 4. Yes, there is no need to take minus pi or plus pi by 4. So this is pi by 4. So argument will be pi minus pi by 4. So 3 pi by 4. So the polar form for this is this. Is this okay? Now you can easily calculate. I was wrong actually. I was taking it into this quadrant. Yes, I was taking it in. So -1 1 argument, polar form you got to know. Easily you can convert any complex number in polar form. Now you must be thinking how it is useful. This polar form is how it is useful. This basically de Moivre has made this form very useful. This is okay now. We can move to this side now. So how you can write 1? How you can write 1 in polar form? Okay. So what theta I should take? I am writing this is z basically 1. You can write 1 in polar form easily. So how will write 1 in polar form? Mod will be 1 and then only one angle. So yes, cos 0 plus iota sine. Learn a method here, and that method says how we proceed now. For 2, n, 2, 3 you already know. For n, 2 and 3 you already know, cube roots of unity and square root you already got to know. I am telling you the general method, and that will fix for 2 and 3 also. Okay, general method says you convert this 1 in polar form. Any number which is given inside this nth root, you convert that to polar form. Then you know if 0 is argument, then 2 and pi plus 0 is also argument. Okay, so 0, what you do? Add 2k pi. This time I am adding k and n, both are same. So 0, I can do it like this. There is no harm now for the argument. There is no harm, because if 0 is argument, then 0 plus 2 n pi will also again be argument. Now de Moivre's theorem says, now what we do, 0 plus 2k pi will be 2k pi only. 2k pi by n plus iota. What I have done, I have taken this n 1 by n inside the angle. And how I am writing it, because de Moivre says that if we have any number cos theta plus iota sin theta, na, any power, we can take that power inside the angle. This is already very well checked. that if you are asked to find out 1 by 2 na, then what you do, take 1 by 2 inside, both values will be same. This is already very well defined result. So it's very simple na. If you have 1 by 3, 1 by 4, easily take that inside and give the answer. But there is one thing to learn. 2k pi, this is to the power 1 by n, okay? Just write it carefully. Okay, now I haven't told you the k values. K will start from 0 and it will go till up to how many roots this equation will have? N. If I am starting from 0, it should go till n minus. Add this also, na? N roots we got to know. So k roots are depending on k now. Fine. So k 2k pi. I will not calculate all the values. I will just tell you only one or two. For 0, bolo, n minus 1. From 1 to n minus 1 terms, and then add this also. N roots only we want, na? Why n plus 1? Then it will be how many roots? N plus 2 roots. And this is polynomial. This polynomial is basically this. So how many roots you can have? N only. Okay, n only, na, and these are the values. Okay, now some of the roots I discussed. 0, for 0 this value will be 1 only, and you very well know that one root will be 1. Another root will be, how you will get the other root? 1. You will substitute k 1. So when you will substitute k 1, so cos 2k pi by n, and it will depend on n also. It's not that only n you will be given. If it is n, answer is this. But if particular value you are getting, like suppose 3, can I connect the to the cube roots now? I correct this question. So take n 3 now. Okay. So n is 3. So k will will start from 0 and will go till up to 2. So k values are 0, and you know the roots also. So it means that roots should be same. So 1 is fine. 1 we were having. Now put k1 n3. So k1 n3. So cos 2k pi 2 pi by 3, 2 pi by 3. 2 pi by 3 value will be, cos 2 pi by 3 is how much? So 180 minus 60, 180 minus 60 second, negative. So cos minus cos 60 is minus half. Fine. Then plus cos sine of 60, no, sine of 120, second quadrant positive. So under root, and now you can see this is omega. This is omega. So cube roots of unity directly I have told you how to calculate, or by this method also you got to know how we calculate. The next value I am sure that will be 100% omega square. 100% omega square. Now any power you will easily calculate. 4, 6, 7, 8, 9, 10 easily you calculate. K values I have given you, n value you will see like what value you have. So any root of any nth root of unity you can calculate now. Okay. Now move to, okay, now De Moivre's theorem. De Moivre's theorem you easily get to know that if we have any power that will go inside. So now I can give you the statement. D spelling is D-E, Moivre's M-O-I-V-R-E-S theorem, and that theorem says that cos theta plus iota sin theta to the power n is basically will be basically cos n theta plus iota sin n theta. This I applied here, na? And it is very well, but this is very true fact. You can put any number, like if I ask you calculate cube, it is very difficult to calculate. But De Moivre's has given a very good solution, 3, 3. In questions now, I just tell you the simple question. De Moivre's theorem is okay? It is any number now. Okay, now how it is useful now, De Moivre's theorem. If suppose question is find the imaginary part of cos theta plus iota sin theta to the power 100 if you don't know de Moivre's theorem, you cannot open it. Even I will not calculate it. It's very difficult. But because of de Moivre's, it is very easy. Now you just see the importance. De Moivre's has given, has simplified. He has given a simple solution, na? Simple. So imaginary part is, and sine 100 theta you all know how to calculate. Like if theta value some pi by 3 or something. Easy? Okay. Now the next thing is, I just be careful now. I'm just changing the question little bit. I just want to check you whether you people will observe that. If I ask you sine theta plus iota cos theta to the power 100 imaginary part. So what basically the problem this time? And it can be negative, it can be negative also, okay? For negative also it works. Very wrong. Yes. Can you please compare the two? This is what I told you for omega also. The form should be of cos theta plus iota sin theta also only. Did you change first? No. First change it, because in this question answer could be same sometimes, but not always it will be. So what to do now? Iota to the power 100 I will take out common first, and then it will be sin theta by iota na, and by 1 upon iota is minus iota, and this will become, now it is perfect, fine. It is perfect now. Now you can compare. Iota to the power 100 is how much? Yes, it is 1, so there is no problem at all. No. What is 100? Imaginary part we are searching. Now you can see the change. Now you can see the change. So please, you are observing all these things, that if something is written na, you have to be very particular that cos is first, then imaginary part is sin theta. It's not that any, now I didn't tell you anything. For omega I think I briefed you like just after that, but here I didn't tell you anything, and you people didn't notice that there is a big change in both the statements. Here the imaginary part is cos, but we cannot apply de Moivre's theorem. So de Moivre's theorem is also not like applicable to any form. There is a particular form, and that is cos theta plus iota sin theta. So the imaginary part, now you can easily see, that is imaginary part is minus sin theta. Fine, minus is also important. So first answer was very wrong. Is it okay? You will be able to do now? Okay, now I think I did one question 6, what was that? What was that? De Moivre's theorem is okay. I think some under root 3 plus iota to the power something I think we did. Can we do the same question with the help of what was that? Yes, 1 plus iota to the power 6n plus 1 minus iota to the power 6n. This was the question now. Can you change it now to quickly to the power 6n plus 1 minus iota to the power 6n. This was the question now, and answer was 0. Answer was 0. Can you do it by using the polar form and de Moivre's theorem? You can easily do 1 plus iota, you can write it as under root 2, and then cos how much? Pi by 4, then iota sin pi by 4 to the power 6n. Easily you can take this 6n inside, easily, fine. So the same thing here with negative sign. Yes, negative sign only. Pi by 4 to the power 6n. Then 2 to the power 3n, because this is half na. So under root 2 to the power 6n, it will be 3n only. 6n by 2. Okay, so now you just take this 6n inside, you can take it. Is this perfect form? Cos iota sine. We can apply de Moivre's theorem. So cos of 6n pi by 4, then iota sine. This we can take out common even. 6n pi by 4. Then from here also 2 to the power 3n, and then again de Moivre's theorem, 6n pi by 4 minus iota. You can see one term sine terms we can cancel. So we are getting 2 into 2 to the power 3n cos 6n pi by 4. This is basically cos 3n pi. Now put any value, because n was what? Odd, na? Put any n odd. Like first 1 I am putting. 3 pi by 2 is how much? First value of n I am taking as 1. 1, 3, 5, 7. Answer should be uniform, na? So cos of 3 pi by 2 is how much? So 180 plus 90, so ultimately 0. Fine. So this is another method for that question. It's up to you, na? Like this method you find, because in that it was I did squaring first. I separated the power, na? Here I applied de Moivre's theorem. Fine. Move to, okay, now I am giving you a good question. That question is something actually you are writing and I am speaking, but you are learning. Okay, now given that this is the last part, now you have learned a lot, everything. Any issues in any of the concept? I don't think so. You have learned everything. So now this is the problem. How you will move now? Tell me. There are two methods now. Which one is better one? De Moivre's. De Moivre's. Now change it now quickly. Change it. So when you will change it by de Moivre's or polar form, so it will be, yes, it will be 2, because so 2 to the power 100, then cos of pi by 6 plus iota sine 2 to the power 100 p plus iota q. So 2 to the power 100 cos of 100 pi by 6 and sine 100 pi by 6. Equating the real and imaginary, you get the answer. Can you change 100 pi by 6 to the particular value? Change this angle quickly. I am just writing. So p value is 2 to the power 100 cos 100 pi by 6 will be, how you can write it? 50 pi by 3 first, and then q value as 2 to the power 100 sine of 50 pi by 3. Fine. Just change the value. Calculate this angle properly. So this should be 2 to the power 100. How you are breaking it? Multiple of pi take. You can break it. Just calculate 50 pi by 3. Na? You people know it, how to calculate. 50 pi by 3 will be equal to how much? Break it. It is equal to how much? So cos 50 pi by 3. You can write it as 2 into 24 pi 48 plus break it. You can break it as 50 16. It will be 16 pi plus pi by 3, 2 pi by 3, sorry. Is it okay? Cos of 16 pi plus pi by 3 is which quadrant? First one. So this is cos 2 pi by 3. This is 120. So again you will write it as pi plus pi by 3, but this time this is pi plus pi by 3. Third quadrant, in third quadrant it is negative. So this is minus cos pi by 3. So minus half. Quickly tell me the value of sine 50 pi by 3 quickly. It will be sine pi plus pi by 3, and in third quadrant sine is positive, so this will be sine of
Third quadrant.
pi plus pi by, wait a minute, let me check now.
Second quadrant.
Yes, it is in third, sorry, second. So again it will be negative, so it is negative pi by, yes, under root 3, but I am giving with me I have plus sign. What mistake I have done then? Actually there is a mistake. Did you people notice?
मैम 1/2 आएगा शायद.
No. Everything is okay. But this is 2 pi by 3 can be written as pi minus pi by 3. This is second quadrant, again cos is negative. There is no problem here. But when you are calculating sine value, again sine of pi minus pi by 3, second quadrant, and it is positive. So here we will get, so this is the answer. I think basically answer is, the trick is important right now, but answer is also important. Plus means plus sign. Don't take it like, is it okay? This question also. Okay, now I have actually this question nowhere you will find, but I want to know the value of iota to the power iota. It is very simple if anybody can get this. Iota to the power iota. Simple value I want to know, and I have told you polar form also.
हाँ हो जाएगा.
How you will write down? Okay, I think before this, let me help you. Euler form. It is not Euler. The correct pronunciation is Euler. For to write the spelling, we can pronounce it Euler.
Cos iota pi by 2 sine iota pi by 2.
How many iota you are adding? Cos iota pi by 2, and then how much? Then iota sine iota. What you are saying?
Iota sine iota pi by 2.
You are telling me the correct answer. This is the value for iota you have taken. Good one. Yes, but I am telling you because that will help you. There is one more form also. There is one more form also for a complex number, and that is basically this. Okay. So cos theta plus iota sin theta, if you have na, you can write it in e to the power iota. This is Euler form. Okay. So in according to Euler form, she has already changed iota. How can you write iota in polar form? First you take under root real part square plus imaginary. So that will be 1, and then cos of because it will be 1 by 0 infinity. So pi by 2 plus iota sin pi by 2 to the power how much? Iota. Okay. Now because de Moivre's theorem, basically here there should be not a complex number. Okay, don't take it inside. But the thing is how you can write this term in this form? This will be e iota pi by 2. This will be, so iota to the power iota becomes e to the power iota pi by 2 to the power iota. So iota square. So the value of this is very simple, e to the power minus pi by 2. Sometimes you people are asked that whether iota to the power iota is a real number, imaginary number, purely imaginary, purely real. This is how you get the option. So this is basically a irrational number. E to the power minus pi by 2 is an irrational number. So I think my notes are over now. I think any questions if you have, because it's been 3 years. Yes, I know. But we can stop, I think 3 minutes. If you have any questions, you are most welcome. Because कर दिया आपने over?